Hello students, this is Mr. Wilsey, and we are going to be looking at learning objective number 6, which involved conversion factors. You would have gotten proficient if you were able to demonstrate that you can convert rates and measurements from one unit to another, and you would have gotten advanced if you were able to convert rates and measurements that involved more than 3 conversion factors. So let's take a look at problem 6.1. We are asked to convert 6.5 feet into inches. Now, this is a conversion factor problem, so we know that we're going to have to set up some train tracks. We don't know exactly how many train tracks we're going to use, but this is the way that you should always start a conversion factor problem. Train tracks equals and then a line. Okay? And the next step is to ask yourself, what do I put where? Well, we're given the 6.5 feet. That is the original quantity. The original quantity always goes up here. 6.5 feet. And then we want to convert 2 units of inches. So inches goes right here. Now, let's ask ourselves, do I know of any conversion factor that links feet and inches? Okay, I know that feet and inches are both measurements of length, so I know of any conversion factors involving length. Well, we can take a look at our best friend here, and voila, it's the first one. 1 foot is equal to 12 inches. So write that down over here. 1 foot equals 12 inches. Now, the question then becomes, what do I put on top and what do I put on bottom? Remember, the goal of train tracks, the purpose of train tracks, is to help you organize these conversion factors. You know that you need to have feet on bottom over here. Okay, you need to have feet on bottom because the feet have to cancel out. Okay, this train track is one big fraction. Stuff on top can cancel out with stuff on bottom. So if feet is on bottom, you know that inches is going to be on top. Now, let's plug in the numbers. We have 1 foot is equal to 12 inches, like that. Now, look at what's left over. Inches on top, inches on top. That's exactly what we want. So, what this is really telling us to do is take 6.5 and multiply it by 12, and then divide by 1. Okay? So, let me get my calculator real quick. Alright. 6.5 times 12 equals 78. So the answer is 78 inches. Alright, let's take a look at problem 6.2. Let's convert 17,500 yards into kilometers. Alright. 6.2. We are converting 17,500 yards into kilometers. Okay, again, first step, as always, is to draw out our train tracks. We don't know how many train tracks we're going to need. Alright, like that. Just the same as the last one. Now, what number do I put up here? That is the number that we're converting from. 17,500 yards. And we are converting 2 kilometers. Now, again, let's ask ourselves, do we know of a conversion factor that relates yards and kilometers? Well, I don't, and neither does this yellow sheet. I don't see of a way to go directly from yards to kilometers. But I do see a way to go from yards to meters, and then some of the extra conversion factors that I asked you to write down, we have a way to go from meters to kilometers. So this conversion is going to take 2 steps. Right? So let's write down what these conversion factors are. we know that 1 yard, one second, there we go, 1 yard is equal to 0.9144 meters. And we know that, let's see, 1 meter is equal to, 1,000 meters is equal to 1 kilometer. All right. We have yards on top here. So we need to have yards on bottom in order to cancel it out. Well, right here we have 1 yard is equal to that many meters. So 1 yard on bottom, and then on top 0.9144 meters. Perfect. Now, we have meters on top of the fraction. Over here we want kilometers on top of the fraction. So we need one more conversion factor here, and it's going to be this one. We're going to put 1,000 meters on the bottom, and we're going to put 1 kilometer on top. That way meters cancel out, and left with kilometers on top, left with kilometers on top. Perfect. Now, let's do this calculation. This is telling us, this set of train tracks is telling us to take 17,500, multiply it by 0.9144, and then divide by 1,000. Alright, so let's do that in our calculators. Remember, as I'm doing this, you're doing the same exact thing. I'm trying to get my light out of the way. So 17,500 times 0.9144 divided by 1,000, 16 and some change. So about 16. So the answer is 16 kilometers. Alright? 16 kilometers. Okay, let's move on to problem 6.3. We are asked to convert 4 pounds 7 ounces into kilograms. Now, this is a little bit more of a challenging one because this is what you might call a compound unit, maybe. We're just now learning about compound inequalities. A compound inequality is 2 inequalities put together. This is 2 measurements put together. 4 pounds, 7 ounces, and we're asked to convert that into kilograms. Now, the easiest way to go about this is to convert, for example, pounds into ounces, and then add the result to the 7 ounces that we already have, and then convert that whole thing into kilograms. So it's going to take 3 steps. Okay, 3 steps. Here's step number 1. Convert 4 pounds into ounces. So we're going to need a train track. Now, let's use our handy dandy best friend. Let's see here. What are we going to need to use? We have pounds, we want ounces. Where is this? Oh, right here. 1 pound is equal to 16 ounces. So I'm going to write that out. Whoops. That was accidental. Don't worry about it. 1 pound is equal to 16 ounces. Okay? Now, we start out with 4 pounds. And so we need to cancel out pounds. So we have pounds on bottom and then 16 ounces on top. Pounds cancel out. This is telling us to take 4 times 16, which is 64. So 64 ounces. Now, we're not done yet. Do not convert this 64 ounces into kilograms yet, because we still have 7 ounces that we need to add on. Okay, so 64 plus 7 is 71. So 71 ounces is the total of this measurement. 4 pounds 7 ounces is equal to 71 ounces. Alright, now let's convert this guy into kilograms. So that's the third step. 71 ounces equals how many kilograms? Okay, so set up your train tracks. Not sure how many we're going to need this time. 71 ounces is what we are converting from. We are converting to kilograms. So let's use our best friend. Let's see, we need to find some relationship between ounces and kilograms. Well, I found this. 1 ounce is equal to 28.35 grams. Is there a way to go from grams to kilograms? Well, yeah, using one of these extra measurements I told you, these extra conversion factors that I told you to write down in your best friend. Grams to kilograms. So, we're going to need these two conversion factors in order to do the conversion. So, 1 ounce is equal to 28.35 grams, and then 1,000 grams is equal to a kilogram. Okay, and those are going to be the two conversion factors we need here. So, what do we need to have on bottom? Well, I need to have ounces on bottom in order to cancel it out. So I'm going to need to have 1 ounce on bottom, and then 28.35 grams on top. Ounces cancel out. I have grams on top. I want kilograms on top, so I'm going to need to have 1,000 grams on the bottom of this fraction so that grams cancel out. And then I'm going to have 1 kilogram on top. Kilograms on top, kilograms on top. Perfect. What this is really telling you to do is take 71, multiply by 28.35, and then divide by 1,000. So, let's do that in our calculators. 71 times 28.35 divided by 1,000. 2, and then a little bit more. So I'm just going to round that to 2. 2 kilograms. Again, I hope that you are writing all of this down with me. I know I'm going a little bit fast, but that's why I do it in a video, so that you can pause it at any point in time in order to get caught back up. Okay, let's do this last one here. We want to convert 125 inches per second into miles per hour. So now we're dealing with rates. Okay, a rate is a fraction, essentially. So we have rate, 125 inches per second. 125 inches per second is equal to how many miles per hour? Let's set up the train tracks here. I'm not sure how many we're going to need, so I'm going to give myself plenty of space. Equal to blah. Now, let's figure out what goes where. 125 inches per second. Now, we already have a fraction going on right here. That's what that slash is. It tells us that this is a fraction. So this train track is already in the form of a fraction. So the best way to put this into the train tracks is to have 125 inches right there, and then a second down here. Alright? Now, we are converting to miles per hour. Now remember, thought bubble here, MPH really stands for miles over hour. Alright? So over here we're going to have miles on top, hours on bottom. Now, you don't need to set it up this way, but it will really, really help you out if you do. Alright? Now, let's figure out what we need to do step by step. First of all, let's just look at the top. We are being asked to convert inches, a unit of length, into miles. So let's think of some relationships that involve inches and miles. Alright? Well, let's see here. I see inches here, I see miles here, but I don't see a way to connect inches directly to miles. But I do see a way to connect inches to feet, and then feet to miles. So it looks like I'm going to need two conversions to convert inches into miles. So let's write down what those conversions are. We know that 1 foot is equal to 12 inches, and then 1 mile is equal to 5,280 feet. Alright, terrific. So let's convert inches into miles now. I have inches on top. I need inches on bottom to cancel it out. So 12 inches is going to be on bottom here. 1 foot's going to be on top, so that inches cancel out. Now I have feet on top. I want miles on top. So I'm going to have feet on bottom in order to cancel that out. So I'm going to use this conversion factor right here, 5,280 feet, and then 1 mile on top. Feet cancel out. Perfect. Now I have miles on top, and I want miles on top. So I have successfully converted inches into miles. But now I need to look at the seconds. I need to be in hours. So how do I do that? Well, I need to think of some conversion factors involving time. Okay? Well, let's take a look at our best friend. And actually, I don't think these are on your best friend. This would be some extra ones that need to be on your best friend. But I mean, they're pretty commonplace, right? We know that 60 seconds is equal to 1 minute, and 60 minutes is equal to 1 hour. And then we could go on, with these time measurements. 24 hours is equal to a day, and then 365 days is equal to a standard year. Okay? These should all be in your head, though. So we're going to need 2 of these conversion factors. Seconds to minutes, minutes to hours. Alright, so let's go ahead and write those down. 60 seconds is equal to 1 minute. 60 minutes is equal to 1 hour. Alright. This is a little bit tricky. I have seconds on bottom. So in order to cancel it out, I need to put seconds on top. Alright, so I'm going to have this conversion factor here. Seconds on top, minutes on bottom. 60 seconds is equal to 1 minute. So seconds cancel out. I have minutes on bottom. I want hours on bottom. So I'm going to need to put this conversion factor in the next slot here. There's going to be 60 minutes in 1 hour. Minutes, minutes. Now let's see what we have. Hours is what's left over. Hours is what I need. Ta-da! So, this train track here tells us what we need to do. Alright? Everything on the top is multiplied together. 125 times 1 times 1 times 60 times 60. And then we're dividing all of that by, this is just an imaginary 1 second here, so 1 times 12 times 5,280 times 1 times 1. Alright, and in reality, we don't even need these times 1s, because you can multiply or divide by 1 and it stays the same. So in reality, this is just 125 times 60 times 60 divided by 12 times 5,280. So let me do that one step at a time here. On top of the fraction, I have 125 times 60 times 60, which is, what is that, 450,000? So I just calculated the numerator here. I'm going to calculate the denominator now. 12 times 5,280. That is 63,360. Now I'm going to take those two numbers, divide the top one by the bottom one, and I get a fraction. Oh, I hate fractions. Now remember, with these TI Inspires, if you get a fraction and you want a decimal, this is all you have to do. Come down here, hit Control, and then hit enter. Wait. Let's just take what we had here, 625 divided by 88. So that's exactly what we have up here. And then do that. Control enter. Bam. 7.1. Okay? 7.1. Now, what units did this have again? 7.1 what? Well, look up here. Miles per hour. Miles per hour. Alright, that's the final answer. Phew! This video is already 20 minutes long. We've only gone through 4 problems. Well, that's math for you, right? Alright, I'm going to put the other problems in a different video.